I think it's going to have to be legislated or something.
Wow, that's profound. What else have you learned in all of the years that you've been doing measurements and testifying in court? Sounds like you've
Well,
learned a lot.
yeah, I have. And me, I'm a meter man. I mean, I like to see my meter, and I like to see if A causes B, if we remove A, B goes away, things like that. To me, life should be black and white, up and down, quite simple, no gray areas. I mean, if you turn the light switch on, the light should come on. If you turn it off, it should go off. But I look at things from an engineering standpoint. But I found that this is very political, and politics shouldn't enter into this. It shouldn't enter it into it all. You take a measurement, it's there. It's not good for you. Here, let's fix it so it isn't. But I think years ago, like electric utilities used to be run by people who probably actually climbed up a pole. Now they're run by MBAs. They don't know an electron from a ground rod, And so the politics, which I didn't think should have any role in something like that's an engineering-based companies.
Was there a particular country that in your exploration and your work with countries in this area that was particularly receptive to you? I know you talked about Canada and Russia, but do you find that there are others that were very receptive?
Oh, sure. I worked with the Republic of Kazakhstan, real close. Government people there, Russia. I was with the Deputy Minister of Health in St. Petersburg. I went to a top-secret military lab that no American had ever been to in Moscow. Yeah, they treated me like a king. I don't have any problems there. Israel, I've been in Israel, the Middle East, Bahrain. I've met with the Deputy Prime Minister of Bahrain. I've had tea with him. In fact, he's got our filters.
That's fantastic. I was going to ask you, we did talk about Europe, but we didn't talk about the Middle East and what the grounding situation is like there.
Well, there they don't have the grounding problem like we have here. But what they have is still have the dirty electricity.
Got it.
There's no civilized, any place that has electricity, that doesn't have the dirty electricity problem right now in the world. And if you read Millam's book, Dirty Electricity, you'll see he's done all kinds of research on this, and he can show with the electrification of America how diseases like cancer and that just exploded.
So this is a real call to set up environments to optimally keep out the dirty electricity and the high frequencies?
Yeah, right. Look, I mean, I'm not going to throw my computer out, and I like watching TV as much as anybody else does in the evening. So the question is, can we use electricity? And can we use it safely? And in my opinion, the answer is yes.
What about for sound studios and sound systems and microphones? That also needs to be filtered separately?
Yes, I think you do. And actually, ideally, and say, well, okay, you have this filter, you have something to sell. Professor Graham and I, originally, we gave these things away until we could no longer give them away anymore financially. It was breaking us. But just so people could get better, because it was, in fact, I think we even put out the schematic and everything on the internet and said, hey, go build your own. But then the things like Underwriters Laboratories started entering in and things like that, so, liability and that. So we had to go and get them made and approved. But we can definitely, you need to have, ideally, Michael Dell builds that laptop computer. He knows what the frequency is that is going back on the line. He could make a tune filter and put it in there for that, and it wouldn't even add $5 to the cost of it. So ideally, we shouldn't have to have any product to sell. What happens is the manufacturers of this equipment, they know that they're putting this stuff back on the line. They should be required to, put tune filters or something right in their equipment so it doesn't crap it off.
What's a tune filter? The same thing?
Well, if we know, for example, if we know a computer's putting 25 kilohertz back on the line, we can make a tune filter for just 25 kilohertz. In other words, it takes out between 24 kilohertz, 26 kilohertz, something like that, right? And so then we know that that's shorted out. So it's not getting back on the line. Where like I'm looking at all this stuff. One computer puts 12.5, another one, the light bulbs put 100 kilohertz back on the line. So I have to make a filter that will take out between 2 kilohertz and, 150 kilohertz.
Is it a filter for each 3-prong plug? Explain
No,
it.
you
I'm
need
kind
to
of
check
confused.
each three-prong plug,
Right?
but you don't need one for each three-prong plug. Like I said, the average home has 2 TVs and 1 computer. The average home takes 20.
Got it. Have you ever had people who were upset that you were educating the public or just bothered by the fact that you're bringing this awareness to light, even though other people have other doctors and people that do measuring? There's got to be other people in the world besides you, probably few like you, but there probably are other people. The question is, are they sharing this?
Obviously, I'm not the most popular guy among the electric utilities, probably. And we've had some issues with people like that. But generally speaking, people, we have the measurements. So there's really not much of an argument that anybody can do from the other side because the measurements are there.
So basically, this type of a product, for example, that I had tried a little over a month ago, would work best in Europe, but not at all in the United States.
It would work in Europe, sure. To discharge the body would definitely, is a benefit. It would discharge you in Europe. It also discharge you here if you didn't plug it in.
Got it. So what's new in your work these days? What are you working on?
Well, right now we're working on instrumentation, developing some meters. Professor Graham and Professor Sam Millam and Professor Havis. We're developing some instruments that are like pickups that you can put on your wrist, and you can see the dirty electricity using an oscilloscope that's in the human body, and then you can also see what's on the building's wires. And then if we turn something on, like a compact fluorescent light, for example, and we see 100 kilohertz all of a sudden, on our wires, then we also see it in the human body. And so if we plug a filter in, for example, then we see the 100 kilohertz disappear, and we see it disappear in the human body. Because people are saying, well, look, I sit out in the middle of the room, how can this dirty electricity that's on a building's wire over there, affect me on the middle of the room? Well, it does. It capacitively couples into you. And so we're working on instrumentation where we can measure in the human body and then change that environment and watch the change in the body.
So we all really need to be having at least one of the meters that you have right now for indoors, correct?
Yeah, you need that meter for indoors. Now, if you put it in, you get miraculously better or feel a lot better and things like that. And now all of a sudden you say, okay, I must be electrically sensitive because I don't feel good when my brother uses his cell phone or my husband or whatever. Okay, then you might want to start cleaning up, the other stuff. But the most biologically active frequencies are between as what's on the building's wires.
Got it. So I guess being in a place like New York, highly congested area with buildings everywhere, you're getting charged up seriously.
All the time, yes.
Wasn't there a report also when you talk about like the cows being out to pasture and getting sick because they're picking up the ground currents? Then really, unless we're in Europe, and I know you said not to worry about walking around, but if you're spending a lot of time outside walking, you are picking up and you are getting charged by the ground currents, correct?
That's true, but if you stand in one place and you put your feet shoulder width apart, we'll be able to measure it and you can see you charge. And you put your feet farther apart, okay, then we'll see you charge up more. And we've done this research with physicists in several places. We have a film out. I don't know, if it's on the internet or where it is now, but we did some research with horses, cows, and of course we were at the time, but we went out right in the middle of a pasture in Michigan, and there was these beautiful horses out there, and we put 2 rods in the ground, 1.5 meters apart, and then we filmed the horses, and we hooked an oscilloscope to these rods, and we could measure the electrical activity. So we put it on a computer and we plotted it, and every time the high frequency transients would come in, the horses would lift their feet because it breaks the circuit. So they were almost like doing a dance out there, in the field, and it correlated 96.5% with the transients that were on the buildings or on the ground.
How sad.
Yeah, actually, you can't even go out in the middle of anywhere and not get a 60-cycle sine wave. In fact, Professor Millam was up in the Sierra Nevada mountains up around 1,000 feet, and he put 2 rods in the ground and he got a 60-cycle sine wave at 3 volts.
God, I wonder if something could be done for the horse's feet.
Well, but we wear shoes most of the time, things like that. but and we don't have that big a potential difference between us, like 1.5 meters. So the voltage